to my madam also, madam, do you know or not? Right? My classes are attending by Spider-Man also. Right? Yeah, someone is saying, see, I will block you. Arey, Spider-Man, mind your language. Mind your language, I will block you. Arey, Gootle. This Gootle is saying something else. Brainless fellow. Arey, serious story going on. He's asking something. Modi ji was busy in. Arey, Johan, please don't disturb the class. Please don't disturb the class. Now come back now. It's okay. It's okay. It's okay. Can we go further? Can we go further? Yeah, fine, perfect. Okay, fine then. Fine. Let's see this one. So assembler input is, listen, assembler input is assembly language. Now some people are asking, sir, what are the outputs are? Lack of space, I am going here. Lack of space, I am going here. So assembler input is assembly language. Some people are asking, sir, what the outputs are? Remember everyone. Output of assembler is relocatable code. Relocatable code. Some people are thinking that. So Reddy sir, why are you going from the bottom to top? Why are you going line like this? Is there any logic? Arey bhaiya, no logic yaar. Lack of space, I am going. Some people, even though in their notes there is a gap is there, still they are going. They are thinking that some logic is going on. Arey bhaiya, no space yaar. No space below assembler, no space. So I am going right hand side, topmost corner. Some people are thinking there is some logic. I will also write like this. Arey bhaiya, no yaar. No bhaiya. Bhaiya, use some common sense. Arey Sayan, please write the notes properly. Use some common sense yaar. Right? Some people are going assembler, below gap is not there. Where I will write? Below gap not there, where I will write? Yeah, I went to that is the reason, right hand side, topmost. Anyhow, relocatable code. So assembler input is assembly language, output is relocatable code. Some people are asking what it means. I will explain. What it means, I will explain within few minutes. Now see correctly now. Assembler, okay. Next one, everyone listen. Next one is linker. Next one is linker. So what the linker will do is it will convert the, right? The linker will convert relocatable. See, relocatable code, relocatable machine code. Output is relocatable machine code. Another name for this one, relocatable assembly language. Another name, relocatable, right? Low level language. Relocatable machine code or machine language. Relocatable machine language. Next one, relocatable assembly language. Relocatable low level language. Now that will be given to the linker. Linker will convert single relocatable machine language, single assembly language, single low level language. What it means, I will explain. Don't worry much, just try this. Within few minutes I will clarify. Yeah, this is the input to loader. This is the input to loader. I will explain. Yeah, I will explain. Just try down. So preprocessor will take high-level language as input. Output is going to be pure high-level language. Compiler will take pure high-level language as input. Output is going to be low-level language, machine language, and assembly language. Then assembler will produce relocatable machine language or relocatable assembly language or relocatable low-level language. That will be given to the linker. Linker will create single relocatable machine language, single assembly language, or single low-level language. That will be given to loader. That will be given to loader. Now observe clearly. Some people are asking, sir, what is the meaning of assembler? Listen everyone. Listen everyone. Everyone careful. Everyone careful. Careful everyone. Everyone careful now. Everyone careful. So whenever you are writing program, initially where is your program? Listen everyone, you are typing a program, program is there. You are typing a program is there in the hard disk. You are saving a program is there in the hard disk. You open a file, program is there in the hard disk. Saving a program, listen, typing time also, saving time also. So every time program is there in the hard disk. Now can you help me now? Program is there in the hard disk, okay. Program is there in the hard disk, okay. But if you want to run the program should go from the hard disk to main memory. If you want to run the program should go from hard disk to main memory. Means it has to move from one place to another place. Program initially there in the hard disk. If you want to run the program, it should go to main memory. It should go to cache memory. Means your program should go while running from hard disk to main memory or hard disk to cache memory. It has to move. Remember. If at all it has to move, you have to give your code to assembler first. What the assembler will do is it will change, right? It will do some changes in the program in such a way that it can relocate to anywhere. Without assembler, if you move the code from the hard disk to main memory or a hard disk to cache memory, you may lose something in the program. There may be some problems will come. Assembler will make the program in such a way that program can go one memory to another memory without losing anything. Without losing anything, your program can move one place to another place because of assembler. Assembler will do necessary changes in the program. It is something like this. Listen, it is something like this one. Listen everyone, it is something like this one. You are the person, you are Indian. You want to go to US. Careful everyone, you are the Indian, you want to go to US. If you want to go to US, you are Indian, there should be a requirement of visa. There is a requirement of visa. If anyone got the visa indication that you are eligible to go from India to US, there is a person who want to go from India to US. If at all you want to go from India to US, you cannot go directly. There is a requirement of visa. Whenever people are giving visa, they will check all the necessary things. Is Indian, you want to go to US, right? Can I give the visa or not? If you go to the visa, the office which is giving visa, he will check all the things which are needed. Is there any problem if I allow him to US? Right? The visa department will check all the things. USA visa department, it will check all. So this is his qualification. You want to go to US, can I allow or not? If I allow, will he create any problem? Will he face any problem? They will ask you, do you know English or not? What is your financial background? Right? If at all, if you say at the visa, right, at the USA, right, USA, if you want to go to the US, right, US visa office, if you go, they will ask you, are you beggar or not? If you are a beggar, US visa people will say, no, we don't allow. There is a one beggar of India want to go to US. So visa required. So definitely visa people will stop you because you are a beggar. Right? Americans may not they don't want one more beggar. In their country already enough beggars are there. Right? So that is the reason they will check account balance also. Are you beggar or not? They will verify. Suppose if you are already beggar, they don't allow you because they have enough beggars. They will verify, do you know English or not? Because you are Indian, total US people will speak in English. Will you get the language or not? So they will verify all. If you are eligible, then only they will give. Assembler is exactly like this. Assembler is like visa office. Like visa office. Assembler is like visa office. Suppose assume that visa people are given the visa indication that you are eligible to go from India to US. Visa stamp is there, indication that you can go from India to US. Similarly, assembler will do that. Without assembler, if you go from the hard disk to main memory, it is almost like without visa, you are going to India to US. If you go without visa India to US, you may not come back. If you go US to India, if you go India to US without visa, I think you may not come back. So I'm clearly saying to every person, assembler is like visa. Right? So visa people will allow you to go from India to US. Similar way, assembler will allow you to go from hard disk to main memory, hard disk to cache memory, or main memory to cache memory. So this is called as relocatable code. Previously also low level, now also low level, but relocatable low level language. Previously also machine language, now also machine language, but relocatable machine language. The difference between this code is both are same. Previously, you don't have a right of going from one place to another place. After assembler, you have the right of going from one place to another place. So like that. You are Indian, you want to go to US, compulsory you have to take visa. Without visa, if you go from India to US, some problems will come. This is called relocatable machine language. Previously I have machine language, now also machine language, but it's a relocatable. Previous one, there may be some problem. If you go from India to US without visa and passport, some problem will come. Same thing here also. Is there anyone who have doubt till now? Sir, I have doubt. Is there anyone who is having doubt till now? Check if anyone having. Yeah, good evening, Bharat. Good evening, Bharat. Good evening, Bharat. Can anyone guess? Anyone having any doubt? Before assembler, low level language. After assembler, relocatable low level language. Before assembler, machine language. After assembler, relocatable machine language. Before assembler, assembly language. After assembler, relocatable assembly language. Check anyone having any doubt. Respond, yaar. Arey man, respond. Arey, can't you respond? Someone is saying, what is the advantage? What is the advantage of going from hard disk to main memory? Hard disk is very slow. Main memory is faster. If the memory is slow, then processor also becomes slow. Processor is the costly one. You want to utilize the processor as fastly as possible. When the processor will give data is coming from hard disk, it will take a lot of time. Processor saying please give data coming from hard disk, it will take a lot of time. So processor unnecessarily waiting. You are wasting processor time. If the data is coming from the main memory, processor will take the data fastly, it will do calculation fastly, then program running become very less time. If the processor is getting data from cache memory, then data is coming so fastly, right? I think the processor will do calculations fastly, then program will take very less time. So it is always better to data is coming from main memory or cache memory. You can take from the hard disk also, but it is too slow. Right? Fine. I think it's perfect. Now listen everyone. Everyone listen. One more interesting story. Please help me. Everyone comment. I am the Indian. I want to go to US. I am the Indian. I want to go to US. I booked the ticket. I went to the one of the online thing. I booked the ticket also. I got the visa also, passport also, everything fine. Tomorrow morning, listen, tomorrow morning, 6 o'clock, my flight is there. Tomorrow morning, 6 o'clock, my flight is there. Can anyone guess today night what I am doing? Tomorrow, 6 o'clock, my flight is there from India to US. I got passport, I got visa, I have ticket, everything okay. Can you guess today night what I am doing in my house? Can anyone guess? Today night what I am doing in my house? Can you make it fast? Tomorrow morning 6 o'clock my flight there. Tomorrow morning 6 o'clock my flight there. I got everything, right? I have ticket, everything is there. Can you guess today night what I am doing? Yeah, I think Jay is saying one nice line, packing. Listen, packing. What is the meaning? All your clothes you will take, you will keep in your bag. All your clothes you will take, you will keep in your bag. The books what in your house, so many clothes are there. You take your clothes, you will keep in your bag. So many books are there. You will take your books and you will keep in your bag. Packing is going on, which is also called linker. Linker will link all the things related to you. You are linking all the things related to you are keeping in your bag. That is called linker. Linker will link all the things associated to your program. Suppose isn't that it is a high level language program to big project. It is a very big project. It is a high level language. It is a high level language of very big project. Let us assume that inside this project there are so many programs. This program internally, listen, this project internally contain, right? Let us assume 20 programs are there. This is a very big project. This project internally contain 20 programs are there. 20 programs. Project name is, right, let us say project name is XYZ, which internally contain 20 programs. So this project high level language code is here. After preprocessor is over, all these 20 programs, pure high level language will come. After giving to compiler, right, all these 20 programs, low level language code will come. Machine language code will come. Assembly language code will come. After assembler, for all these 20 programs, relocatable machine language will come. Relocatable assembly language will come. Relocatable low level language will come. After giving to linker, so it will make all the 20 into one single file or one single, right? Just it will link all of them which are necessary. So single relocatable machine language. If at all linker got to know, right, one of the file is not related, it will neglect it. Whenever you are doing packing in your house, so many clothes are there. You will take only your clothes, you will keep in your bag. Right? Next one. Right? And in your house, so many books are there. You will take only your books, you will keep in your bag. In the similar way, linker also knows, right, to run this particular project, to run the project XYZ, which files really needed, linker knows. So it will take all the necessary file, you will make it as a single, so then it will become single relocatable machine language. It is something like package, right? Packing is going on. Tomorrow morning 6 o'clock your flight is there. Today night, if my guess is correct, you are doing packing. Now some people are asking, listen, sir, if at all linker is not there, what is the problem? If at all linker is not there, what the problem is? If at all linker is not there, what the problem is? It is like without packing, right? Tomorrow morning flight 6 o'clock, you are not done any packing. Today night you eat like a buffalo. And you slept. No packing is there. Morning 6 o'clock flight is there. You woke up at 4 o'clock without any packing. You take randomly something. You run away to airport. You went to the airport and you went inside the flight. You get down in the US. You went to inside the US. Inside US, your room you went. But as soon as you went inside the room, you got to know that you lost your cell phone. You lost your documents. You lost one of your gold item. You lost because you are not done packing properly, right? I think cell phone maybe you lost. Maybe some books maybe you lost. Some clothes maybe you lost. So again you have to come back. Again you have to book the flight again from US to India. Again you have to come back. So 20,000 phone purpose, 20K phone purpose, going to US 1 lakh, coming to US one more 1 lakh, total 2 lakhs you have to spend for 20,000 phone. For 20,000 phone you have to spend 20, right, approximately 2 lakh. So it is better to go after linking. Some people are asking, sir, whenever language is processing, without linker I will do. Without linker, if you do, your program, right? Relocatable code. I think linking is not there. Relocatable code only will goes to the processor. While running, one of the file is missing. Again, you have to come back. So it is a troublesome task. The best idea is please link it. All the necessary things will link. Then you will get the single relocatable machine language that will go to loader. Now it is a correct time to ask you, please help me. After linking is over, where is your program? Can anyone comment? After linking is over, where is your program? Please help me. After linking is over, where is your program? Make it fast. No. After linking is over, where is your program? Still in the hard disk. We are making ready. No, still in the hard disk only. See, before preprocessor hard disk, after preprocessor hard disk, before compiler hard disk, after compiler hard disk, before assembler hard disk, after assembler also hard disk, before linker hard disk, after linker also hard disk. Now also program is there in the hard disk only. The only thing is everything ready. So packing also done. Listen, packing also done. Then now you are at the airport. After packing is done, now you are at the airport. Now listen. After going to airport, now you went inside the flight. You sit. Then you went to the US. This one, loader will load the program. Loader will load the program from hard disk to main memory. Loader will load the program from hard disk to main memory. Now listen. This program is xyz.c, right? If at all it is a C compiler, xyz.c, right? Then after loading is over, now your program becomes xyz.exe, executable. Now I can say executable file. Now I will say executable file. Now your program is there in the main memory. Loading is what the loader will do? Loader will load the program from hard disk to main memory. Loader will load the program from hard disk to main memory. Loader will load the program from hard disk to main memory. Remember, before loading, program is there in the hard disk. After loading is over, program is there in the main memory. Now your program became xyz.exe, means it is executable. Now it is executable. Now your program is there in the hard, right, main memory. Can anyone guess where is the program now? I want answer from you. Where is the program now? Make it fast now. Loader also completed. Where is the program now? Loader also completed. Where is the program now? Now it is there in the main memory. Now your program, after loader also done, means now your program is there in the main memory. Some people are asking, now my program is there in the main memory. Because of loader also done, my program is there in the main memory. Sir, what is the name of that state, sir? That state is called, my program is there in the main memory. Now that state is called ready state. It is something like BTech is completed. It is something like 4 years BTech is completed successfully. Now it is there in the main memory. That state is called a ready state. That state is called a ready state. No, ready state. Now can anyone help you now? Now your program is running or waiting? Now your program is there in the main memory. Now your program is there in the main memory. Is it waiting or running? Now your program is there in the main memory. Is it running or waiting? Now your program is there in the main memory. Is it running or waiting? Waiting, which is called a ready state. Ready state. Some people are asking, sir, why it is waiting, sir? CPU busy with someone else. Now CPU is busy with someone else. Let me give rough diagram. It is actually part of the OS. It is actually part of the OS. See this one. Let's see this one. Everyone listen. Program typing. Everyone listen. Program typing. Program saving. Compilation. Assembler. Linker. Loader. All these things. This is called new state. This is called new state. Now after new state is over, loader will kept the program from hard disk to main memory. Now this is called a ready state. Now program is there in the main memory. It is the new state. This entire story is called new state. It is there in the hard disk. Now your program enter into the main memory. Now this state is called ready state. See, those people who are ready to run by CPU, they all are waiting. That state is called a ready state. Can you help me know which memory it is? ROM or RAM? RAM memory, random access memory. In the main memory, RAM area, they are waiting. Some people are asking, why is waiting? CPU busy with someone else. That the reason they are waiting. Now some people are asking, now sir, suppose that CPU is free, then what the answer? Now we will shift from here to here. This is called running state. CPU free. CPU is free. Now it will go to running state. CPU free. Now it is going to running state. Whenever this running is going on, suppose isn't that program P1 is running. Program P1 is initially there in the ready state. Now because of CPU is free, right? P1 is running here. Unfortunately, whenever P1 is running, some other high priority processes came, or high priority program is came. Then what CPU will say to P1 is, hello P1, you wait, right? Hello P1, please you wait, because higher priority person is came, so I cannot run you further. Please wait. So he will go back. P1 is initially waiting in the ready state. Now CPU said that I am free. Hello P1, you can come. P1 is running by CPU. Unfortunately, higher priority person is came. So P1 replaced by P2. Now P1 will go back to right ready state. Now some people are saying that, sir, whenever P2 is running, let us assume that some interrupt came. Some maybe input required, maybe printer required, some IO devices required. This is called IO wait. No, you no need to write. This will come in the operating system. You no need to write. Whenever a program is running by processor, if at all any IO problem will come, maybe input required, maybe output printer required. Unfortunately, to give input keyboard required, keyboard not available. To get the output printer required, printer is not available. Now CPU will say to the right P2, hello P2, can you wait in the IO wait state? So now at the time, right, processor may take P1 again. Right, so I think the P2 is waiting in the IO wait state. Whenever P2, everything is successfully completed, he is waiting for something. It is happened. He will go back here and once again he will wait.